Okay, so this question, star X has a luminosity L and an apparent brightness B. Star X is at a distance D from Earth. Star Y has the same apparent brightness as X but is 4 times more luminous. What is the distance of star Y from Earth? Okay, well, because we're seeing stuff on luminosity, apparent brightness, okay, this actually is the discussion and the unit that comes after the Stefan Boltzmann law and the Wien's displacement law in the unit. Okay, so right after that, it goes and leads into apparent brightness, kind of incorporating all the quantities and the properties involved. Anyway, the formula that you will be using for a problem like this is the following: B equals L over 4 pi d squared. Okay, B is apparent brightness, L is luminosity, D is the distance. Okay, and this is also found in your data booklets. Okay, so well, notice that the problem is giving us information in terms of X. Okay, so typical kind of question from IB. They give you two things. One is in terms of the other. So for star X, the luminosity is just L. Okay, that's our basis. It also has an apparent brightness of B. Okay, and the distance is just the letter D. So actually, this formula here, we can just use that as is for X. Okay. Now, for star Y, it's telling us that it has the same apparent brightness, meaning the value for B for star Y must be the same. Okay. And in terms of the luminosity, despite of having the same apparent brightness, the luminosity is 4 times that of X. So I will write that as 4L because L is X's brightness, apparent brightness, but for Y, it will be 4 times that value. The question is now asking us to find the distance, or what is the distance, how will you express that, of star Y from Earth? Okay, so I don't know that, so I'll put a question mark here. I don't quite know what this is. Okay, how will I express that distance? Okay, it's not a certain value, but how will it be expressed? And these are our choices over here. Okay, well, first of all, because the apparent brightness is the same, okay, I technically should still have this value for Y. Okay, so what does that mean? So before anything else, if I were to just ignore the fact that X is here, okay, I will just replace L with the following. Okay, for L, because we're talking about Y now. Okay, now this is the question: what will I insert here to that letter D so that this will still equal this one here at the top? Now, it may seem confusing, but again, it all goes down to the fact that the apparent brightness for both X and Y must be equal. So if I'm going to change this distance, provided that the luminosity is 4 times that of X, what can this quantity be so that when I simplify things, I still end up at this particular value? Again, the reason for that is because your apparent brightness must be the same. So if the apparent brightness for X is this, then the apparent brightness for Y, provided that the luminosity is 4 times that of X, must eventually simplify to this. Okay, and the way to do that, okay, you can even just check each one, okay, manually check each one, is make this 2. And if you simplify this, you will notice that it will cancel out and you will end up with this one. Okay, you can double check. So this technically should still be for X, okay, which would also is supposed to be for Y. Okay, the 4 and 4 here will cancel, so I will be left with L at the numerator. Pi will stay there. Now this entire quantity squared, okay, so 2 times 2 is 4, and then I have the D squared. Notice that I still end up with the same expression for the luminosity for X. Therefore, the value for the distance, or the expression for the distance, must be 2D, because that value will allow us to end up with the same expression for the apparent brightness. Okay, so I hope this helps.